the brave ones at the last panel of the day, hopefully with an interesting subject. So we'll try to decipher this solution X, and we'll see whether hydrogen can be one of these solutions to come forward. So in this last session, I'm joined up from an esteemed panel. We will have one more guest that is slightly late, Ulrich. Not usual for Germans, but yeah, he's a bit late. Maybe it's the Greek taxi driver that has the issue. Therefore, we can now kindly ask for my co-panelists to introduce themselves, so we can start the interesting discussion. George.
Thank you for staying until now. So, George Touloupas, Senior Director of Technology and Quality for Solar, Storage and Green Hydrogen, or Clean Energy Associates.
Hello from me. My name is Faidon Prokopios from ATHENS. I'm the Manufacturer Decarbonization Director, and I'm going to give the input from the off-taker part regarding green hydrogen.
Hello from my side, I'm Sideris. First of all, I would like to thank the organization for the kind invitation to participate in the hydrogen panel, and of course to thank the colleagues here. I'm coming from Econergy Internationale, a Tel Aviv-based company that developing 6 gigawatt projects in Europe. And currently we are trying to step into the hydrogen application, and that's why I'm here to help the situation in Greece altogether.
Excellent, thank you for that. Gentlemen, I would like to maybe start the discussion by giving us an outline statement and setting the scene of it. So let's start with your own thoughts about green hydrogen and whether it is something which, especially the renewable energy industry, should pay as much attention as we seem to be paying. George?
Absolutely.
Absolutely.
So we're talking about terawatts of installed electrolyzers that will be needed to produce the quantities that we shall need in the next decades. And for that, we'll need terawatts of renewables. So that's serious.
And what Titan has to add to that?
I will try to make a quick introduction, not just Titan, but as a cement producer. But I will use the analogies of Titan in order to explain the challenges that an industrial off-taker has in front of him. So Titan, and that could be the same for any cement industry or for any steel industry, has a pledge to reduce CO2 emissions by 2030 according to a certain methodology. In our case, our target is to reduce it by approximately 35% to reach anyhow 500 kilograms of CO2 per ton of cementitious. I know this metric does not mean much, but a reduction of 25%, which is nowadays quite standard in the industrial meters, by 2030 is an ambitious target. And there are ways to do it in the cement industry, there are different ways in the steel industry, and hydrogen can play a significant part in it. Can, I say can, because it is an excellent fuel. There is no process guy in the cement industry who will not tell you that he likes hydrogen as a fuel. But it is quite expensive, it needs terawatts, and the question is not so much how many terawatts are needed, but at what cost. And this is the point where the two sides, the off-taker and the developer, have to meet. And on that we'll come in later, so that is introduction.
Excellent. Stathis, your view as a developer?
You as a developer, hydrogen economy has a lot of applications. Some of these applications are in our attention, and with the strength and the experience of renewable sources that we can enhance, we try to put some of these applications all together and do combined technologies. As a fuel, we are into it, although we are not oil and gas refineries, but I think some developers should be a small part of it as a fuel.
Excellent. I still have my reservations personally on hydrogen on many issues, and I'm here to be educated as well. And I would like to start perhaps with you, Faidon, looking at it from the back, because I think for any application of a new technology, you need to start with the off-taker. You need to start discussing about volumes, prices, and then walk your way back and reverse engineer the process. So, in your own sort of experience and with whatever you can publicly share, can you share the plans of? Here we have Ulrich as well. There's a round of applause for Ulrich. It's the great taxi driver. All right, excellent. So before we start on the questions, so a quick introduction and an opening statement on hydrogen.
Okay.
Yeah, so I can take mine.
Yes, hello everybody. Thanks for the welcome. My name is Ulrich Laumanns. I'm working as a project manager for GIZ in Greece. GIZ is a German public company working in the field of international cooperation for sustainable development. And here in Greece, we are currently implementing a project which is looking at the promotion of hydrogen. So basically, the objective of the project is to improve the framework conditions for the production, the transport, and the consumption of hydrogen in Greece.
Excellent. Can we have a bottle of water for Ulrich, please? Because I think his voice, the heat is not there. Excellent. So coming back to you, Faidon, perhaps with the question, give us the utilization from ATHENS and the cement industry point of view. What sort of volumes are we talking about in the Greek context? In the Greek context, okay, and perhaps in what extension the cement industry would require those sort of volumes in the short term. Because we can talk about 2050, but it's just too far away. Let's try to put things in perspective up to 2030, perhaps.
Okay, in the Greek context only, or you want to speak European?
Well, you choose.
Okay, so the pledge of the European Union, probably you've heard about it, the original pledge was 10 million tons of hydrogen production by 2030. Then with the REPowerEU, they added additional volumes. So I don't remember the numbers by heart, but I think it was additional production of 5 million tons and maybe imports of another 10 million tons. If the numbers are not correct, please bear with me, but that is the order of magnitude. Is that enough to cover the requirements of the cement industry on a European scale? Yes. By 2030, if the European cement industry could absorb approximately 400,000 tons of hydrogen according to, let's say, a conservative scenario, and by 2040 it could reach even 1 million tons. So no problem for the cement industry to absorb the availability of hydrogen. In terms of the Greek context, as you asked, by 2030 one could assume that the Greek cement industry, the cement plants in Greece, could absorb roughly 10 to 20,000 tons of hydrogen on an annual basis. These numbers depend, of course, on the utilization rate of the cement plants, how much a cement plant would work, what would be the market, but let's keep these numbers as an order of magnitude. The main question, however, is, and this is something that the project developer should always ask the industrial off-taker, what do you want to replace with hydrogen? What do you want to achieve? There is a mindset, we see it repeatedly, that many developers come and say, we have hydrogen and with it we will replace natural gas. There are many cases where that is just not the question. For the cement industry, for the average European cement plant, the challenge is to replace, the question is to replace petcoke with hydrogen as a main fuel. Petcoke is I don't know how familiar you are, it's a fuel that is a byproduct from refineries in abundance and quite cheap. And that makes the challenge even greater. Of course, if you add the CO2 price, the E from the ETS, that makes the project more feasible, more attractive. But still, at current electricity prices, hydrogen would not be able to compete with petrol.
If you could give me a range of a price, where is the price or the sweet point, the sweet spot that we need to hit in order for a company like yours or the industry, your industry, not talking about Titan specifically, to be in order to start thinking about replacing petrol with hydrogen?
If we would have a magic stick and we could do every wish that we have right now, with the current CO2 price of approximately 100 euros per ton of CO2, the electricity cost for the production of hydrogen should be in the range of 20 to 30 euros per megawatt hour in order to be able to have a feasible option against petcoke. And that also does not fully include the CAPEX requirements for the development of the equipment, both in the cement plant as well for the developer and for the electrolyzer. So I'm sure that right now that you heard this, you lost interest if you are developers. But, and there is a huge but, this is under the assumption that the ETS price remains stable at 100 euros per ton, which most probably is not going to happen, unfortunately for the industrial emitter. Most predictions from various institutions point at the price development at the CO2 price of 150, 160 euros by 2030, and there's a lot of discussions about that. We can speak for another hour about that. If the price reaches 150 euros, then immediately the range for the electricity price increases. So you can have not 30 euros per megawatt hour, 50 euros per megawatt hour. For me, the most reliable scenario, and that is just me speaking, I know that most developers are aiming for prices of 80 to 90 euros per megawatt hour. That is the sweet spot for them, depending on the market, but okay, that is a very nice case for most developers. For that to materialize, to be able to provide hydrogen at this electricity price, the CO2 price would have to reach 300 euros per ton. So with these numbers that I give you, I think you have an idea. If you would go tomorrow to cement producer, check the ETS price, check the petcoke price, then you have your baseline, check the net calorific values, and then you can start developing your baseline scenario to speak with the cement producer. And the cement producers are interested. Hydrogen is a great fuel, but the price. Sorry for interrupting.
No. Stathis, I think Faidon gave us a very interesting point, and I would like your comment perhaps, and give us your opinion, combine it perhaps with the curtailment issues that we are going to be facing, and also the negative prices. Because when we have curtailment on negative prices, then that becomes a more viable option.
Yeah, okay, regarding the curtailments, at the moment we need a lot of capacity to run the electrolyzers, okay? And if we put the model only on the curtailments, then we are not going to go anywhere. In order to have a good scale capacity, we need to over-dimension our PV panels. In this case, I don't see for the moment any combination with the curtailments. We go straightforward to more aggressive policies with over-dimensioned PV parks to get the capacity we need at the electrolyzers level.
Ulrich, coming back to you perhaps, we need to understand numbers. We've heard some numbers from the cement industry, but it would be good to give a context in the discussion about what do we need perhaps in Greece, and what is the target for 2030, and perhaps what is it needed to change immediately in the policy level in order to allow deployment of production facilities.
Yeah, okay, that's a very interesting question. Concerning targets, at the moment here in Greece we don't have any official targets yet. There was a national committee that was established back in 2020 for the preparation of a national hydrogen strategy. This national committee has prepared a kind of report which it has submitted to the Greek Ministry of Environment and Energy. And based on this report, the idea was to prepare a national strategy for promotion of hydrogen in Greece. This has not happened until now. It's also, let's say, a discussion that is a bit related to the update of the National Energy and Climate Plan. Maybe you've already heard during the conference that Greece has set new, more ambitious targets for the development of renewables in the country. So, yeah, by 2030, up to 80, or at least 80% of electricity should come from renewables. And as part of this update of the National Energy and Climate Plan, also, let's say, it has specific targets for hydrogen, which is supposed to be introduced. The first version of this new targets has been published by the Greek government at the beginning of this year, in January. There was an initial target of 1.2 gigawatts of electrolyzer capacity. It was supposed to be installed until 2030. So basically from zero that we have now of electrolyzer capacity to go to 1.2 gigas in just 7 years from now, it's quite an ambitious objective, I would say. But yeah, on the other hand, it's also with the developments in other European member states. Maybe you've just seen in the press this morning that Spain, another Mediterranean country, has just increased its national targets for electrolyzers from 4 gigawatts to 11 gigawatts by 2030. Portugal has also increased its national target for 2030 to 5 gigawatts. So the question is, let's say, Greece being a country with a lot of potential in the field of solar energy and wind energy. This target seems to make sense in my view.
So first,
could you be more?
first step is to set the policy, to set targets, and then create a favorable policy. Do you see any subsidies in order to drive the initial deployment of hydrolyzer within the Greek, again, context, in the Greek market?
Okay, the first thing is to have a target, the next thing is to have policies that are going to help you to achieve this target. And if you want to set a target, then you also have to think as a next step what is necessary in order to achieve this target. And as we've just heard, the costs of green hydrogen production at the moment is much higher than the cost of natural gas hydrogen production from natural gas, with steam reforming and not talking about energy products like petcoke, for example, where the business case is even worse. So I guess that at least for the initial period for the next year, some kind of financial incentives are going to be necessary to cover this cost gap and to make, let's say, green hydrogen cost competitive with fossil-based alternatives.
George, you are a very seasoned and experienced international consultant with a company that knows all the value chain. What do you see as the key points for the development of the hydrogen market? And perhaps it would be good to share a best case example from your own experience.
Yes, I'm very lucky to work in a global company and parading in front of you a real case of super big projects planned around the world, from the US, Australia, or even the Middle East. So I would say that it is very, very clear, first of all, the use cases. So for me, the winner is green ammonia by far, and then refining is coming second, and at the very bottom, maybe for transportation, refueling stations, or even e-fuels. But these are relatively niche. These again are not real projects. These are they're all mature projects, but they're big companies with huge track record behind them, so they're very serious. Now, the key is the LCOH, which Faidon unfortunately mismentioned. So I'm going to ask you later. So it's how many euros or dollars or whatever per kilogram. That's the key metric. And don't let anybody fool you with dollars or euros per megawatt hour, right? It doesn't work like that. It should be per kilogram. So LCOH depends on three things. One is the CAPEX of the equipment. Second is the capacity factor or utilization rate, which is a very important assumption. And of course, the third one is the LCOE, which was mentioned by Faidon. And so you need to have everything fall in place, right, for hydrogen to become as cheap as €1 per kilogram or 1.5, because that's what you need to decarbonize these difficult industries like cement and steel, etc. Because you have to compete with very, very cheap, dirty fuels. So to have all in fall in place, you need very low LCOE. Okay? How do you do that? Definitely not by selling at 80 or 90 per megawatt hour. You have to reach very low figures. Maybe this is not feasible today, but with these fantastic new panels, the new generations that are coming, that will be very cheap, very low cost, and higher energy yield, we're getting there. So the industry, the big industry really helping is racing towards the correct direction. And there's a lot of space for improvement. So we're not there yet. The end of the road of this downward curve is far into the future. So that's very good. Now, CAPEX-wise, currently we have very, very low-cost equipment produced in China. Everybody knows that. Bloomberg has made a big deal out of it. Right? So we know where we can buy very low-cost equipment. Now, we'll see how the European manufacturer will react. They don't like that. And how they're going to put their act together, scale up, and bring down their costs. In theory, they could. We're not there yet. But if you want to buy, and everybody's looking, by the way, buying very low-cost alkaline electrolyzers from China for these mega projects. Okay, there is a reason for that. So the utilization factor is also the third element that is super important, because if you don't operate 100% or 24/7, you operate at curtailment, or 30% if you like, or something like that, your CAPEX triples or quadruples, or etc. So 50% double your CAPEX. Roughly, it's not accurate. So the utilization is very important. With delegated tasks, that gets very complicated. So we need to have really green hydrogen, not fake green hydrogen. That's why the delegated tasks have their additionality, for example. But at the same time, that pushes the cost up by 30 or 40%.
Well, if you were wondering why you would stay to the last panel of the day, you just had your strategy lined up with these four fantastic speakers here. Stathis, I will come back to you. As a developer, what do you see as resource limitations, and what sort of adaptations do we need to make now in the legislative side of things in order to allow companies like you to start hydrogen projects?
Before we go to the technical aspects or environmental or the chain of the hydrogen development, I would say that the biggest restriction is the clear vision from the government to set up a roadmap of how they will move forward. If we don't have a clear target where we go and how the hydrogen and what is the role of the hydrogen will play the next years in Greece, this is a very big restriction. What we want a clear vision, a roadmap for hydrogen, and what percent. The second environmental or other aspects regarding the development, I think there is experience to deal with this. First, we need as a move correct and clear steps from the government about hydrogen.
Would you see water, for example, as a limited resource?
Okay, yeah, water. Of course, water it is an issue. Even getting the things worse with energy climate, the next European energy climate, that it will put even more strict policy to the water use. There are places that you can develop a hydrogen for sure, but then it needs a very rescheduling where you should put this factory forward.
So if tomorrow you want to start and install a hydrogen anywhere it is, would you know where to go for the licensing?
For Econergy, we know where to go. We worked for these issues 3 years ago. We have spot mapped Greece. We see the future difficulties, and for us, we know, we have a view where to move on.
Now I'm talking about locations. I'm talking about from a legislative licensing.
Okay, yeah, there is an issue. We have to follow the situation in Greece, although we get, I think that all these are coming as copies from the European Union. So we have a clue of where the legislation and regulation will go at the end.
Faidon, what are your immediate sort of plans? Would you see your group going after hydrogen or trying to figure out hydrogen alone, or are you in favor of creating partnerships and JVs, especially at this initial stage? So do you see off-takers willing to engage with the wider market and create potential synergies and partnerships, or do you see that you have enough capital or you're big enough that you can actually pursue things on your own, which we might have cases here in this instance?
This is a very good question. At that stage, as before I was explaining the view from the cement industry, so not only us, the cement industry right now would not be excessively interested in investing large amounts to develop hydrogen economy, since it still is not competitive with the main fuel of the industry. And please always remember that the main fuel of the industry is always additionally, it has the additional weight of the CO2 tax. So as the CO2 tax increases, things might change. We are interested as Titan and some other cement companies, we are interested in investigating the technical challenges of feeding hydrogen, because we believe that not sooner or later, probably later, hydrogen will be, if not the main fuel, one of the important fuels of the industry. We cannot predict exactly when. And as I said, a major part of it is electricity price. Having said that, and going now away from the cement industry, because I speak all the time about cement, and maybe I'm doing hydrogen some wrong, because there are other industries where hydrogen, green hydrogen, is really even now interesting, and that is the refineries. We know that the refineries, and you hear about this in the Greek press, are investigating projects, not at huge scale. We're not talking about 200 megawatt electrolyzers, we're talking about more contained projects, but even a 5 or 10 megawatt electrolyzer is something in today's environment in Greece, it's a bold step. And they are interested because there, again, it's the question, with what do I have to compete as hydrogen producer? In the case of the refinery, they have to compete with grey hydrogen they're producing from their steam methane reformer. So there, the price of €1 per kilogram is something that is the target, 1.5, exactly as you said before. For cement plants, €1 per kilogram is just not competitive. For steel industry also, that is another question. It's not so much regarding the combustion itself, it's more about the chemical process. So, in the end, to summarize what I said and to answer the question, we as cement and as Titan, we're investigating solutions for hydrogen on small scale to start identifying the limits of our process system, to be ready to adapt to the hydrogen economy which will come. Refineries are more aggressive into that because the price difference between the main fuel the main component, is smaller than the price difference that we have. And steel in Greece is not that much interested yet, but they will be quite interested in the future. So I think this gives quite good overview.
Yeah.
And of course, we can talk with more details every time, but this is the general thing.
Ulrich, what can we expect from the EU or Greece in a sense of either financial tools or these sort of use cases we've been hearing in the news a lot about hydrogen valleys? What are hydrogen valleys and what can we expect from the EU and Greece as financial tools in the immediate sort of future?
Yeah, what is really interesting is that actually the EU has put together a huge amount of financing of hydrogen during the past years. So this has been, of course, also related to the adoption of the European Hydrogen Strategy in 2020, and together with this, there have been quite a lot of different possibilities for the financing of hydrogen that have opened up at the European level. First of all, this has been the Recovery and Resilience Facility. Of course, it's not dedicated specifically to hydrogen, but many member states are using this funding for the promotion of investments also in the hydrogen sector. And as far as I know, Greece has submitted a proposal to the Commission to also include, let's say, a program for the financing of biomethane and green hydrogen pilot projects in the context of this additional funding under the Recovery EU, so, which is also coming from the Recovery and Resilience Facility. Secondly, a lot of financing, especially for research and development, has been provided both under Horizon Europe as well as the Clean Hydrogen Partnership, which is focusing, of course, exclusively on hydrogen. And in this context, a lot of hydrogen valleys in the whole of Europe have actually also been funded from the European Commission. For Greece until now, there are 2 hydrogen valleys that have already been approved for funding. This is one hydrogen valley in Corinthia, where also the refineries of water oil are involved together with some other local actors. The second hydrogen valley is in Crete. This is, let's say, also a project developer from the renewable energy sector, which is coordinating this hydrogen valley. And there's a third application for hydrogen valley in Western Macedonia, which has just been submitted, and we have to see if it's going to be approved for financing. For regions like Western Macedonia, which are trying to make the transition from lignite to a more cleaner or greener future, fossil-free future, there's also the Just Transition Fund, which is available and which has also been used here in Greece for the financing of the first investment projects. For example, this electrolyzer factory in Western Macedonia that ATHENS technologies is.
But this is for the production of electrolyzers, production of components, not production of hydrogen.
For the production of hydrogen, another interesting financing opportunity at the European level is the Innovation Fund, which provides funding for large-scale investments in the field of green hydrogen, and also as part of the Innovation Fund, a part of the budget has been allocated to the so-called European Hydrogen Bank, which is going to organize its first annuals in autumn. And so this first tender, a budget of 800 million euros have been allocated. And this budget is exclusively for the production of green hydrogen. And so this could be something interesting to also for the developers.
Being from West Macedonia, I would question the use case of hydrogen in West Macedonia. But coming to you, perhaps, George, there's been a lot of discussion about applications of hydrogen. I think it was a common theme in the panel that we need to start from the use case and work our way backwards. And we're discussing about applications in transportation, applications in injection hydrogen in current gas pipelines. What is your opinion on that. I mean, I think you've touched upon it on your last comment, but can we actually see a way forward with more traditional, perhaps, applications?
Yes, and one thing I mentioned is what these big developers globally are looking at, right, which is one thing. That can include a multitude of uses. So some of them could be co-firing in existing gas power plants. We do have such a project in the US. But that's a small percentage. Okay? This is one existing idea. Also refueling for long distance transportation. Again, these are inception stage, not very mature yet, but definitely existing uses. So green ammonia, refining, methanol production, existing 100 million tons today are produced dirtily. We need to take this out in the next few years, okay? And then probably increase this number to like 150, 200, there are various scenarios by 2050 to decarbonize industries such as aviation, shipping, cement, steel industry, other industries that need high heat.
So there are essentially two lines here. Let's green the dirty stuff. So let's clean ourselves up. So let's start replacing gray or black hydrogen with green hydrogen, and that's a rule on its own. And then we can see existing applications, and then we have new applications, which essentially, but also here we have a competition between hydrogen, hydrogen and batteries, transportation, for example.
Pit coke, which is like a fraction of $1 or euro per kilowatt hour. Sorry, per kilogram. That's in hydrogen terms, right? Yeah. So that's the last thing we'll do probably. Okay. So it's difficulty, competitiveness, prioritize. The hydrogen ladder, I strongly suggest.
Ladder, Michael Ulrich.
Refer to that. It's a very educational, simple diagram.
Yeah.
And it's quite sound in physics.
I think it grounded a lot of people in the hydrogen conference a year ago as an opening keynote as well. George, do we have bankable suppliers in the electrolysis sector? Is it considered bankable?
Before I answer that, may I add something to what Faidon said, that blue is gray plus the cost of carbon capture. So it's like more expensive than gray, and since green hydrogen is looking at being cheaper than gray, so blue is not really a long-term viable solution.
Also, we haven't seen many
Also, yeah, exactly. But our hydrogen is not mature, and the life cycle emissions are a big question mark. Methane linkage.
No, it's a very good question. Now we're opening, but I think it's interesting for the developers. I assume majority here are developers. So this is a question that the refineries, as the first client of hydrogen, not only in Greece, they are globally trying to understand what is better. Blue hydrogen would be perfect because they have already steam methane reformer installations that produce grey hydrogen. And if they want to prolong the viability of these assets, they are looking into blue hydrogen. But the truth is, they are competing with too many emitters for the room in the storage facilities, in the CO2 storage facilities. So more likely, it seems green hydrogen will prevail. It's just the only problem that the refineries have, and again, it comes again to the electricity price. The main problem is they need so large volumes, and electricity is so expensive in their mind that it just does not seem to make sense. But this might change in the future. It's really a very interesting question how the refineries will deal with that.
Coming back to your question, maybe George, on the bankability of electrolyzers?
Yeah, no, they're not bankable.
They're not bankable.
In what sense? It's a 100-year-old technology for alkaline, a bit less, 70-year-olds for 60-year-old for PEM, proton exchange membrane. However, everything has been very small volume, very small scale. So really, the projects that are being discussed, someone told me today about 1 gigawatt project project in Greece, for example. So we're talking about terawatts. So that's just the scale of the projects is unprecedented. So we're going from a container to a big factory. So they're not bankable, and the warranties they're giving are not great. 5 years, because they really don't trust the equipment, right? And the operational conditions, the viability of the renewable energy injection, the current, these are big questions.
It would be good perhaps in the next discussion about hydrogen to have a bank or a banker in the panel to see how they
Define bankable, by the way.
define bankable, yes, but it would be good to have the view of a financier of how would they treat the electrolysis project. I think we've answered the single decision on policy. I think, as we said, let's start with the basics. Let's get the vision and the roadmap first. I think Efstathios was very open to that and very sort of straightforward. Do you think we need a feed-in tariff for injection in the gas grid? So this injection to the gas grid, we have a limitation of 5% by the EU. Do we think there were some critics about whether it's economic or not, or whether it's sustainable? Would anyone like to pick on that?
Yeah, maybe I can take this one. 5% is what the Commission has proposed. The Parliament has proposed 3%. In the end, maybe the government had 3% or something like that. The reason for this is basically it's not a very good idea to inject hydrogen, to produce hydrogen, to inject it into the natural gas grid. There are so many off-takers in the industry, in the transport sector, that need pure hydrogen. So if you just inject it and blend it with ordinary natural gas, basically hydrogen loses its chemical properties, and you cannot use it for all these applications. So I think in general, natural gas injection of hydrogen should not be encouraged and could be used as a kind of fallback option if there's no possibility that you can sell your hydrogen anywhere else, especially at the beginning of the market development. I think this could make sense like this as a kind of backup. But yeah, it's definitely not sustainable.
So we shouldn't subsidize injection of gas. That's the opinion of the
No, I think you can subsidize the production and the hydrogen that has been produced is going to find its customers. But if you just inject it into the natural gas network, you're basically wasting a lot of public resources. And it's not the most efficient way to decarbonize these hard to decarbonize sectors like steel or refineries or something.
And then you have to burn it, right? So waste, more waste.
And you were discussing about volumetric issues as well in the pipeline.
Yeah, because the gas is less dense.
Yeah. Let's combine two more questions, and I think we will then ask you to have some closing statements. What load factors does an electrolyzer need to run to be economic? And also there's another one, H2 plants with battery and renewable generation require an active, optimized plant control. How do you see the market in the software solution to simplify this operation? So perhaps going into more technical matters here, Sideris, George, anyone would like to pick this?
Sure.
Yeah, you can share.
So yeah, that's a fantastic question. Batteries are being discussed. I'm afraid they're very expensive, so if you put batteries, then it will be very short duration, just to do some basic things like black start, smoothing the renewable current curve, if you like. And definitely controls are very important to protect the electrolyzers and to sustain the warranties. So this is a very, very important function, the control system of the electrolyzer system, and the wrapping of the warranty around the operational profile and the various metrics.
So from a developer's point of view?
What we are checking this period of time is that what operational profile we want from this project and from these combined technologies. It's it's a process of still learning how to put inside and in which place the electrolyzer. But we are developing combined technologies with electrolyzer to play a factor in combined technologies project.
Faidon, last remarks, closing statement.
I try to show how the off-takers are saying it, and the truth is, it is a complicated exercise. As we said before, different sectors, different requirements, different feasibilities for hydrogen. But if one would look forward, the truth is the hydrogen economy will come. It will come to stay. To which extent, it's very difficult to predict. In our sector, it's very difficult to predict when hydrogen will become a main fuel. E-fuels is a different story. George touched base upon that, and we could discuss additionally on that, but that needs an additional market. Let's not go into that yet. If, as an off-taker, if I would have to ask something from the developers, it would be to rethink the current business model of most developers, to be able to approach lower electricity prices for the production of the hydrogen. Does it make sense? Most developers today would say no. But if one considers the scale that the cement plant would require in hydrogen, and thus in terawatts and gigawatt hours, that is substantial.
Thanks.
I would add to this, but a good combination of all these technologies could support all the project. I think that the key point here is how we can achieve a lower cost of energy to run the electrolyzers, and at the moment we see that over-dimension projects is a path we are looking at it.
George?
It's a very long road to a very high peak. So it will happen, it will take time because it's so much challenging, and I'm very bullish on global zero, by the way, by the end of the decade. So on that front, I'm very optimistic.
This is going to be your flag, yeah?
Yes.
That's it. And Ulrich, you came last, so you have the privilege of closing this panel discussion.
Okay, thanks a lot. Okay, basically I think what is missing in Greece is a strategy, a plan. Now we want to develop the hydrogen sector. And Greece is one of the few countries in Europe that hasn't adopted yet a national hydrogen strategy. I think it's also interesting to look a bit at what is happening in other European countries in the field of hydrogen. In Greece until now there's not so much which has happened up to this point, but of course Greece has an enormous potential for the production of hydrogen, especially if during the next years you're going to reach a point where 100% of the electricity can be produced from renewables. I think we are very, very fast moving towards this point. Then the question is, let's say, is hydrogen also something that Greece could potentially export as a product in order to generate income for the national economy? So this is also something that could be interesting for the future, or let's say at least become something like a hub for the import of hydrogen from the Middle East, North Africa. I think your country is in a very good position to take this forward.
And on those thoughts, ladies and gentlemen, and demonstrating my geekiness, quoting the Mandalorian, this is the way. All right. So thank you very much for staying with us until this hour. You've been the brave ones. A big round of applause for our panel.